I've come up with some other problem. So the question is, move all the zeros to end of the array while maintaining the relative order of the other elements. So this is the question where you have given a array containing integers, guys. Now output should look something like this. Okay, so basically we have to move all these zeros to the end of the array. Now in this particular case, so we have to maintain the order of remaining elements 1, 1, 12, and only zeros to be moved to the end of the array, right? So let me take one more example. Let's say your input array looks like something like this. It starts with 0, then 2, then again 0, then 5, again 0, so let's say 9, let's say 3. Okay, now the output should look like 2 followed by 5 followed by 9 followed by 3 followed by whatever the zeros. We have 3 zeros and 3 zeros should be at the end of the array. So if you see here, we are not changing the position of course we are changing the position, but we are not changing the position of non-zero elements relative to each other, right? Relative order of the other elements is not changed, only 0 should be moved to the right side of the array, guys. Now how do we implement this? So the standard here is you have to use two-pointer approach, right? So it is one of the coding techniques, so where you follow a two-pointer and based on the pointers you will move the you'll swap the elements, guys. Okay, so let me take one pointer I'll say I equal to 0. I will use this to point to 0th elements. Now into j equal to 0, j less than array dot length and then j plus plus. Now very quite straightforward, so we are iterating through that. Okay, so let's say if you put a ref condition, nums of j is not equal to 0, that means what we have to do? We have to do a swap. I'll tell you why we have to do a swap. Let me swap it and I equal to 0. Now here j equal to 0 and nums of j also equal to 0, right? Now this condition won't be satisfied, guys. Why? Because we are only checking for non-zero elements in this particular if condition, right? Now what happens? We'll go to the next increment. I is still referring to 0, but j is incrementing. That is the idea, guys. I will stay as is until and unless I will stay as is in its index until and unless we find a swap criteria, right? So in the next iteration, j equal to 1 and array of j equal to 1, guys. Now if you see here, this nums of j is equal to 1, right? This condition will match. At this point of time, I is still pointing to some 0th element, and we have to swap this particular elements, guys. Now what will happen? We'll do the swap. This is a standard swap that we use. Now after this swap, what will happen? Your array will look something like this, right? 1, 0, 0, 1, 12. This is after second iteration, right? Because we are swapping first and second element, because I is pointing to still this first one, so we swapped it. After the swap, this is how it looks like, right? Now because I is we are swapping, we have to move the I, right? So because the swap is performed, right? So now I will be referring to 1, guys. Okay, now for the next increment, done. What is the next increment? J equal to 2. What is nums of j this time? This particular array, what is nums of j? 0. Nums of j equal to 0, so nothing doing, so this condition won't be executed. What is the next iteration? J equal to 3. Now j equal to 3, what is nums of j equal to 3? 1. We got a non-zero element for j, but still I is pointing to this particular number, because it will only get incremented when the swap happens, guys. So I is still pointing to 1, index of 1, which is 0, right? I will also write it down here, I equal to 0, right? Now in this particular third iteration, what will happen? J is non-zero element, but I is 0 element. We have to do a swap, right? So we do a swap. After swapping, what will happen? This one has to be swapped with this index. Okay, so here 1 will come here and 0 will come here, guys. Okay, this, and I will get modified, right? We are incrementing I, right? Now what will happen? We'll increment the I. Now what is the I equal to 2, guys, and now it is 0 basically. Second position, what is there? 0, 1, 2. 0 is only there. That's fine. Now we go to the next iteration. Z equal to 4. Now Z equal to 4. What is the element? Z equal to 4. 12, guys. Which is 12. Right? Again, we have to do a swap because it's a non-zero element. I is still pointing to 0th element. Right? So we do the swap again. So once we do the swap, this particular 0 will get replaced with 12, and this 0 will get swapped over here in this position. Right? And we are incrementing the I again, right? We are incrementing the I again, and I will be pointing to what will be, I will be pointing to 0, which is our third index. Okay, now at this point of time we are out of array elements, right? So, and there is nothing to execute, and we'll come out of the loop and we'll have to return nums, case. That means we are returning the array itself. So we did not use any another array, we just swapped the existing elements. Okay, so very good example. But let's say how what about if it does not start with a 0, right? So let's say we are starting with only 2, okay, and we have only 1 0 in it, right? Now we will see how does it work, guys. Now this time output will be 2 1 1 and 12 comma 0. So this is how we are expecting, right? Now let me try to run the program, see if it works. Yeah, so here, so this is what we expected, right? 2 1 1 12 0. So it worked. Now the problem is, there is no problem actually, this will absolutely work fine. So we'll do one more round for this particular input array. Okay, so let's start with the first one, j equal to 1, and j in this case j equal to 2, which is non-zero. So we will have a normal array only at this point of time, so we'll do a swap. So let me remove this, we'll add it whenever required in the first iteration. Okay, so we'll do a swap because it's non-zero. We'll have to do a swap, right? So but I is not pointing to 0, right? So what will happen? So I will anyway be incremented, yes, I will anyway be incremented. So we'll see how it works. Okay, so what all I wanted to say is this solution works even if it does not start with zeros. Okay, so how does it work? We'll see. So let's say j equal to 1, j equal to 0, and nums of j equal to 2, right, in the very first iteration. Now what will happen? So we have to do the swap because if j is non-zero, right? So we'll do the swap. After swapping, so this is a traditional swap. So what will happen after the swap? How does the array look like, right? It is only the first element, right? So first element will get replaced with the first element. What will change? Nothing will change, right? Because I is also pointing to the same, so it will be the same. First element will get swapped with the first element, same, nothing will change, right? Now what happens to the I? I is incrementing I, we are incrementing I. Now I equal to 1, we are incrementing I. Okay, and what is nums of I? We are not finding it out, but what is nums of I now? 1, right? That's it. We do this operation and we'll go to the next iteration. Now j equal to 1, okay, j equal to 1, again non-zero element, we have to do the swap, nice. Same element will get swapped again because it is pointing to, as long as I is pointing to non-zero, right, same element will get swapped. So nothing changing here, still it is also the same index, so 1 will get replaced with 1 only, same swap, so nothing will happen, right? You understand, right? So nothing will happen here. So now I will be incremented to 2 and 2 is equal to 0. So even if starting with non-zero elements, swap will happen with the same elements. Now if you see here, we are doing some redundant operations, right? So if we so there is a way to optimize this code, guys, that I will tell. Okay, so we'll complete this iteration. Okay, so next time j equal to 2. What is j equal to 2? J equal to 0. Now we don't do the swap, guys, because it's 0th element, right? This condition won't match, we don't do the swap. So we'll go to the next iteration. J equal to 3. J equal to 3 equal to 1. Nums of j equal to 1. Right? Now we are this particular element. Now we have to do the swap. Now if you see here, I is still pointing to 0 element. Now it makes sense to swap. Now we'll swap the element and I will be incremented. I'll be 3. I'll be 3. I'll be still be pointing to 0, because we are doing a swap operation. What we are swapping with? A non-zero element with a 0th element, right? So I will always be pointing to 0. If I is not pointing to 0, nums of I is not 0, we'll replace with the same number, right? So it doesn't affect anything. But we are doing a lot of unwanted operations, guys. That is the problem here, right? So we'll go to the next iteration. J equal to 4 and nums of j at this time is 12. Again non-zero element, we have to swap, right? So I is pointing to the third index, we will just swap it. Done. I will be incremented to 4 and nums of I still be pointing to 0. That's it, guys. So next iteration will come out of the loop and will return the numbers. So this is the array we are getting. Okay, now there is another solution to this, which will be optimization over the existing solution, guys. So I'll tell you that. Now here what we are doing, we are doing every time, even though we don't want it, we don't want the swap, we are doing, because I is still pointing to 0 or not, we are not finding it out, right? So we are doing, for example, in this case, if starting with 2, we are still swapping with the same number even though I is not pointing to 0, right? So that can be avoided using an AND condition here, right? Only do the swaps if I is 0, right? If j is not equal to 0 and I is 0, then only do the swaps, right? Now the entire operation, redundant operations what we have in this case will get dramatically reduced, right? Now instead of incrementing I over here, what I will do, I'll calculate separate thing, right? If nums of I is not equal to 0, then I plus plus. Okay, so because it doesn't make sense to keep I plus plus over there now, right? We were not incrementing, because if it is not 0, then only we have to increment, right? So in the previous case, even if I is equal to 0, we make a swap, right? But we have to separate it out in this case so that it will be incremented only if it is not 0, guys. Okay, so let's take an example. Okay, let's take an example. In the previous example only, we'll take this previous example. So let's say this is our array, guys. 2 comma 1 comma 0 comma 1 comma 12. Now let's say j equal to 0, guys, and nums of j equal to 2. Now what we are finding it out, the very first time I equal to 0, alright, and nums of I equal to 2, right? At this time this condition won't be matched. Okay, so we are avoiding that loop, that iteration, guys, not loop, that iteration, right? Because if both are non-zero only, we are not going to this loop, right? Now what we have to do, we have to increment away, right? If it I is non-zero, so there is no point keeping the I in the same position. That is why we are incrementing here, guys, right? We are writing a separate if statement, right? If it is non-zero, then we are trying to increment I. Okay, now what will happen? I equal to 1 and nums of I equal to 1. Nums of I equal to 1. Okay, Now next iteration, what will happen? Z equal to 1 and nums of z equal to 1, and at this point of time I equal to I will be 1, right? Nums of I equal to 1. Again the condition won't match, this will not get executed, right? This condition won't be matched, right? It's not 0, I is not pointing to 0, we won't do the swapping. So unnecessary swaps we are going to avoid in this particular approach, guys. And again here what will happen? I is not pointing to 1, so we have to increment, right? So we will increment this until we find num of I equal to 0, guys. So in this particular case became 0, right? Now what will happen in the next iteration? J equal to 2 and j equal to 0, and I is already 2 by this time, and nums of I is already 0. Again it won't execute because j is pointing to 0, guys. We will only do a slap when j is not 0, nums of j is not 0, and nums of I is equal to 0, because we wanted to point it out to 0 element, and if j encounters any non-zero element, then only we do a swap. Okay, so at this point of time we are not going to do a swap, right? So I did not write a array because we did not perform any swap and swaps on the array until this point of time, right? So array won't be affected until this point of time. We're not making any changes to the array, right? Now again we'll do the we don't do the swap. Again we'll come here, but still at this point of time what is happening? I is pointing to 0, guys, so we don't do anything. This condition won't be matched, but we'll go to the next iteration. So j equal to 3, and this time it will be 1, guys, and this time I will be pointing to 0, but j is non-zero. This time we are going to swap, right? So after the swap, what will happen? Second element or second index, I is second index, right? Second index which should be swapped with third index. Now what will happen? So 2 comma 1, what is second index, guys? So second index is 0, right? It should be swapped with third index. Third index is 1. So after the swap it's something like this, right? So in this particular array 0 should be swapped with 1. Okay, done. Now what will happen? We have already swapped, but I equal to 2 is non-zero, guys, right? So we have to increment the I. If you increment the I, it will come over here, and it is already pointing to 0. Now we'll go to the next iteration, 4, right? J equal to nums j equal to 12. So again, guys, so nums of j is non-zero and I is equal to 0, so we have to do a swap. So we have to do a swap with what? We have to do index swapping between 4 and I equal to 3, guys. This is 3 because we incremented here, na? Yeah. Now if you do a swap, it will come out here. It might look little complicated, but if you understand what is the logic, right, it's straightforward, guys. So even if I run the program now, it should give me the same output, guys. Yeah. So this is how it works, guys. So so all the easy level problems, right, so we should be able to solve, especially with this 2-pointer sliding window patterns, right, especially related to the arrays and strings. If you are comfortable for test automation, right, so you'll be able to clear any medium level product based company also. You can clear with this easy level problems for test automation. That's all for today, guys. Thank you.